Hey guys, let's take a look at number 10 in section 10.6. So you're given in the problem that the function 1 over 1 minus x can be represented by the power function n equals 0 to infinity of x to the nth power. And of course this is only convergent if x is some number strictly less than 1. The absolute value of x is less than 1. Otherwise it would diverge off to infinity. Now, we're asked to expand 4 over 1 minus x, and the center of our interval of convergence has to be at -4. Okay, so what I need to do is I'm going to replace the value x with the x minus the center, x minus c, and you see, well, that's going to become x minus 4. This is just like in Calc 1 when we did our equation of the tangent function. You said it had to be x minus a, and you said, well, this is x minus c, x minus a -4. That's going to give me x plus 4 here. Now, I'm going to take my general equation that I'm supposed to expand, and I can say, so 4 over 1 minus x, I have to replace x. Instead of x, it has to be an x plus 4. But you can't just replace a minus x with a x plus 4 without making up for that. So here I know I'm really subtracting 4 when I put that plus 4 in there, so I'll add 4 to the outside. That plus 4 is going to join this 1 and give me this fraction right here, 4 over 5 minus the group x plus 4. But now what I know is that my power series function has to equal 1 over 1 minus some term. So I can say, well, I need to get this into that format. No problem. I factor a 4 out of the numerator and I factor a 5 out of the denominator. When I do that, of course, that makes your numerator 1. It makes the first term in the denominator 1, which is what it's supposed to be. But now this group x plus 4 becomes the group x plus 4 over 5. And then you say, okay, I'm supposed to fit this into this format, so I can see x needs to be replaced inside my summation. If I know that this summation works for 1 over 1 minus x, well, now I have 1 over 1 minus this group. So that group, that's what I tried to show here, that this shows we need to replace x inside the series with the group x plus 4 over 5. So that's what I do down here. Now I can say then the function 4 over 1 minus x is going to equal 4/5, I can't forget about that I had to factor out, times the series where x is replaced with what I had to have here in the place of x plus 4 over 5. X was to the nth, so this group is to the nth. So this is going to be my power series representing this function. Now, on achieve, it doesn't want any coefficient out in front. It just says your series is equal to. So you have to multiply this 4/5 into the series function. When I multiply in the 4, I don't have any other powers of 4, so I'll just bring that out in front. But the 5 can multiply the 5 to the n in the denominator and give me a 5 to the n plus 1 in the denominator. So I say this is just the power series from n equals 0 to infinity of 4 times the group x plus 4 to the n over 5 to the n plus 1. Now, that should be our first answer. Our second answer is what is the interval of convergence? Interval of convergence, just like in the beginning where it said it would only converge if the absolute value of x is less than 1. And when you think about that, it's because this is a geometric series. And you know geometric series only converge if the common ratio, the absolute value of it, is a number less than 1. So that's why I said, yet again, this would converge if the absolute value of r is less than 1. I think it's a little bit easier to see in this format, but either way, you can see every successive term is going to be multiplied by yet another power of x plus 4 and yet another power of 5. Whether I look at this or this is a little easier to see. But I'll go ahead and say, well, then if the absolute value of r needs to be less than 1, all that means is that this numerator needs to be less than that denominator. And it could be opposite signs as well. So I say, well, the absolute value of x plus 4 has to be strictly less than 5 in order for that common ratio to be less than 1. That gives me that x plus 4 has to be less than 5 or greater than -5. I subtract 4 in all three portions and I get that x has to be between -9 and 1, which then tells you, hey, your interval of convergence for x is that it is convergent if x is any value between -9 and 1. Hope this helps out with number 10 in section 10.6. It's a good problem.